Hello and welcome to this video. My name is David Thorne. This is now the first video or the first lesson in my Python sets for beginners. And in this video, we're going to give you a complete understanding of all about sets. And sets are super important in Python. So it's something that you really need to listen to and understand. And this is the first of 3 videos that I'm going to be making. So without any further ado, let's get started. Anyway, we're going to show multiple ways to create a set in Python. Now, the first easiest way to do it is literally saying set. Now, this is built into the Python language, so you don't need to do any imports or add any libraries or anything like that. You can literally just say set. And obviously, set is a key word also in Python, so you can't use it as a variable or anything like that. And this is just basically saying, hey, create me an empty set using the set function, right? And now empty set now takes up, as you can see, the type of set. And if we print this out, it's going to be nothing more than say set there, because it's an empty set. Now, if you're a fan of set theory like me, then you'll understand what sets are. But throughout the 3 videos, you will definitely understand what a set is and how we work with it. So let's just keep pushing on, all right? They're important to understand. And sets are not lists, and sets are not arrays, okay? I just want you to understand they are sets. So creating a set with curly braces with multiple elements. And so as you can see here, we are creating a set using the curly braces. Now, if you've done any JavaScript or done any other programming languages, then you'll be quite, you won't be new to this basically. But here we're saying that set with braces is going to have 5 elements in it, 1, 2, 3, 4, and 5. Now, sets are unordered lists, right? Which they are also have unique items. So if we said then 1, 2, 3, 4, 5, and 5, it would remove 5 because it can only have unique items in there. All right, so when you start duplicating it, they're already quite efficient to remove any duplicates. Now we can create a set from a list. As you can see, using the square brackets notation, this is going to create a list. And now we can instantiate or call the set function, sorry, not instantiate, just call the set function now with a list rather than a set, all right? Now, we didn't call it with anything here, but this is really synonymous to this by giving it an empty array or an empty set. And this is really quite important to understand what this means in set theory or in sets. This is the empty set. Now, there is another way of writing it, but for the time being, we're just going to call it an empty set. Now, and every set contains the empty set, all right? So it's yeah. Anyway, so we're using a list here to generate a set, and because a list is iterable, just the same as what a set is, the set function can take on an iterable, and it just creates a new set. Now, list to set, this is not this list, all right? This is gone through and iterated through every item inside of this list, and it's created a new set, so they are not linked to one another whatsoever. So now creating a set from a tuple. Okay, this is the same thing. This is going to iterate through all of the items inside of here specifically, and then it's going to create another set with this. Now, creating a set from a string, unique characters. And as we know already, that a string is nothing more than a collection of characters. Now, when I say collection, that's not a set, because obviously hello has 2 L's here, and they would not be distinct, right? So HELO would be a distinct set. But this is a collection of characters, and the set will then iterate through each letter and add each one to the set. And obviously when it gets to L, it's going to jump over that because it exists already within inside of the set. So this is now how to convert a string to a set. Now, creating a set with set comprehension, this is a bit more complicated, a bit more advanced, but I thought I'd leave it in there anyway. So we are iterating through this range from 0 through to 5, and it's 5 is exclusive, so it's going to include 0, 1, 2, 3, and 4, but it's going to exclude 5. So it means that this is going to go for 0 in this range, for 1, for 2, for 3, for, and then for 4 in this range. And this X is then going to take the place of 1, also 1 is then to the power of 2, and then 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, and so on. So this set is going to be have all of these values in there. All right, but just take it at face value right now, and we'll make another whole bunch of videos about about set comprehension. Okay, but I don't want you to get too worried about it. This is more an advanced way, but I wanted to show you this. So creating a set from a dictionary, key onlys. Now I also don't want you to get too flustered about dictionaries. If you don't know what they are, okay, this is only going to use, so this is the key and this is the value. If you haven't done JavaScript or any other programming languages, don't worry about it. This is the key to an element, and this is then the value of the element. But I'm going to do another video all about dictionaries. So just try and trust me here. And this dicta set is basically just going to be A, B, and C. Right? It's going to be the keys only. So this is another way that you can create a set using the set function. Okay, nearly there. Creating a set from a range. Well, we've seen this already, is that range is going to make a set from 0, including 0, 1, 2, 3, and 4. All right, so range to set, this is going to return an iterable as well, right? Which means that it can create all of these different items in it. And then finally, we can create a set from a set with braces. So set with braces was the first one here. And so, but this is a copy of a set, all right? I don't want you to think that this set is the same as this set. They have the same contents, right? They look exactly the same, but they are different. So if you edited this set wouldn't change. And if you edited this set, the copy of set wouldn't change either, all right? So when you pass in a collection, an array, or whatever it is through the function, it is then going to rebuild a new set from those keys and values, or the keys, shall we say, or the items that you've given it. So now we have an understanding of how to create a set and basically what it is. Let's just start going through the other usage examples now. So now we want to understand how we can add elements to a set. As we've seen already, we can create a set using the curly braces or with the set function and so on. But if we want to add one, this is basically, it's giving you an object that you can use. And we can say myset.add, and we're going to then add the number 4, a single element to my set. We can also say update. Now, what I want you to make you aware is that this set is being mutated, right? It's being changed. It's not immutable, so it's not read only. So the add function that we're calling here on line 8 is modifying this one set. It's not returning anything. As you can see, it's returning none. So it's returning none, but it's not returning anything. You wouldn't be able to start doing anything after it, okay? So it's modifying the set itself. And when we come down here, update is doing the same, but this is going to add these items within inside of this list to the set. And I wanted to make sure that you understand that we're adding 4 here, and then we're adding 5, 6, 7, and 3. Well, 3 is already there, so it's going to literally ignore 3, right? And if we print out my set, you see here we get 1, 2, 3, 4, 5, 6, and 7. Now, this is not the order that they're going to be in. They might be in this order, or they could be in a different order completely, because sets are an unordered list or unordered set, all right? Order is not of any relevance, okay? But just for the sake of clarity here, that's how we are saying they're going to be outputted if this time here. Okay, so we've now seen the add function and also the update function, all right? Let's now skip over to example 3, sorry. Now we're going to be removing elements from a set. So my set, as we already discussed, is a mutable set. We can change it. And something that I want you to remember here is that remove does not fail gracefully. Okay, so we are saying myset.remove 3, right? And because 3 exists already, it's going to remove that one item. It's going to return none as well, as you can see. So this is going to change, it's going to modify this myset itself. And so any other references to this one set are obviously going to update once this is called. There's going to be side effects on it, is what I'm trying to say. Now discard, on the other hand, this fails gracefully. So it's going to say, hey, if 5 exists in this one set, please remove it or remove it. Else don't worry, don't do anything. So it's just gonna fail gracefully. Now, if we were to then say myset.remove3 once again down here, we would then notice that we're going to get this exception. So we'd have to catch it. We haven't been through try and catch or try and accept exceptions right now, but just trust me that your code is going to fail horribly, all right, because of that. So you have to test. If you're using remove, it's really more beneficial to check if that 3 is in the set, but we're going to get to that later, all right? And as you can see, it would output here 1, 2, and 4 because 3 has been removed and 5 has been removed. Okay, let's move on to example 4 now. So now accessing elements in a set. So as we can see here, my set has 1, 2, 3, 4, and 5 elements in it, and we can iterate over the set. An element is then going to be 1, and then 2, then 3, then 4, then 5. It could be in any order, all right? Just because we've put it in this order right here doesn't mean to say it's going to be in that order, but it's going to output all of the elements in the set, all right? So remember, it's an unordered set. The order doesn't matter. Anyway, that's how you then iterate, just like a normal array would as well, okay? Now, checking if an element exists in a set. As we said with removing the item, it's always worthwhile, obviously, to check. So print element in set here, we would want to say if 3 is in my set, right, then it would be true. And then you would say then my set remove 3, for example, all right? Yes, you could just use discard, we'll do it nice and gracefully, but if you want to be explicit and check it, then I would use then is the element in a set first of all right? And as you can see here, we're just using 6 in my set, and it's not, so it would output false, all right? So you can see how you would then test if my set contains this element, or if this element is in this one set, and so on. There's a different way of rewording it for different programming languages if you come from other languages. So example 6, now a set union operation. Well, if you're not aware what union operations are, we now have 2 sets, 1, 2, 3, and then 1, 2, 3, and then 3, 4, and 5. So 2 sets. And to take the union of it is basically it's going to put the 2 sets together, all right? And it is going to remove any repeated items. In this sense, 3 is in the set too. So set 1 contains 3 already, so it doesn't need to add it. But it doesn't contain 4 and it doesn't contain 5. So the union set of this, as you can see down below, would be 1, 2, 3, 4, and 5. Now, because sets are distinct, if we had 3 in this set, it wouldn't be in this set. It would just be removed anyway upon being created or upon assigning that value to this one set. So it's just a way of basically kind of mapping all of the sets together to get a consolidated overview of all of the items in both sets, all right? So let's now move on to the next example. And here we're going to get the intersection. And the intersection is kind of the reverse of union. So here we've got set 1 and 2, and set 1 has the numbers of 1, 2, and 3. Set 2 has then 3, 4, and 5. So the intersection of it is where they both meet, right? And in this scenario, they both meet at 3. So if we wrote the numbers out, and I think if you don't know what intersection is, it's okay. And whoops. And we come to this line, and we assume that that's a 0 is going to be then nothing in there, right? So that's non-existent. And this next one then has, 3, 4, and 5. So please just understand the 0 is just meaning there's non-existent. That thing doesn't exist there, all right? But this set has 3, 4, and 5. And as we can see that on the number line, they intersect at 3. So the output is going to be 3, okay? But best of, just try it out yourself and yeah, see how it works. It's not difficult, trust me. Don't get flustered about it. So set difference operation. And let's just have a look at what the example says here. Returns the difference of 2 or more sets as a new set, i.e. all elements that are in this set but not the others. And you can see that we've got 1 and 2 are in this set, but not in the others. So we see the difference of it, right? And obviously 3 is in set 2 and set 1, 4 as well, and 5 is not in either of them, okay? That's why it's just saying, hey, 1 and 2 are in my set, but they're not in this set. So to be the same, let's call it, then I'd have to have 1 and 2 in it as well. And we're going to move on to what that means in the next videos, all right? Or in the next example, sorry. Okay, set symmetric difference. Now you have to appreciate that symmetry, it means that it's looking like each other on each side. So at one point within this one set, we can see that 3 and 3, they mirror each other, all right? It doesn't matter about what position they're in, but that one set has a mirroring item that are the same. Now, 1 is not included in set 2, and 2 is not included in set 2 either. And to go in reverse, 5 is not in set 1, and 4 is not in set 1 either, right? So it means that 3 is a symmetric, right? There's a difference. And as we can see here, the difference is 1, 2, 4, and 5, all right? Because the difference between the two is that set 2 doesn't have 1 and 2, and set 2 doesn't have 4 and 5. So that is the difference that is between the two arrays, okay? And as you can see here, return the symmetric difference of two sets as a new set, i.e. all elements that are in exactly one of the sets, right? 3 is not there, okay, because 3 is in set 1 and in set 2. That's not exactly one of the sets, okay? And this is what's really important. And if we then put 4 in here and we run this one again, you would then see 1, 2, and 5, because the symmetric difference is saying that it has to be distinct, right? It cannot be in both. It cannot be in both sets. It can only be in exactly one set, and it's then the difference. So something that's not. So when you put the two together, they're not. It's. I'm not very good at explaining this, but the example explains itself here. Okay, and if you have any questions on it, or if I confused you a little bit, then please don't worry. So set comprehensions. Now, this gets a little bit more difficult, all right? But what's going on here is that we're using a for loop. So we are saying this is nothing different than saying for x in range and then 1 through to 6. So it's going to start at 1. So it's going to start at 1, and then it's going to go to 2, to 3, to 4, to 5, and it's not going to do 6, all right? And what's going to happen here is it's going to then say x to the power of 2, so 1 times 1, and that's going to be then added to the set. So if we had my set here, if we had my set here, then this would be nothing more than saying my set is here is then adds, and then 1 to the power of 2, all right? Or 1 times 1. This is basically what's happening here. So every single time it iterates through one of these items here, we're going to take x and we are then going to increase the value of it by the power of 2, all right? And that's then going to return the squared set. So it's basically this is what is happening, all right? Yeah. But that's set comprehensions is a little bit more there needs to be a different tutorial in this in itself, all right? But I just wanted to show you how you can then use sets for this, all right? And as we can see, it prints out 1, 4, 9, 16, and 25. Let's just do it again for you to see 1, 4, 9, 16, and 25, all right? Okay, so this is now a good introduction to giving you a complete understanding of sets. Now, sets are a fundamental, important part in programming, all right? Especially when you want to deal with distinct items, all right? If you want to have an array of lots and lots of items, who cares whether they're duplicates or not? Then you would use lists. You wouldn't use sets. But if you want to be able to merge items together and knowing that you've done it efficiently in the background, then sets are really the way to move forward. Now, there are ways and means of making it immutable, but for the sake of this one video, we're just keeping them nice and simple. All right, but in the next video, we're going to dig a little bit deeper into this. Now, I'm a big fan of set theory, and don't get me wrong, there are some times where your brain freezes a little bit when you try and think about this, because especially in set theory, it can get quite complicated quite quickly. All right, but the more and more you do it, the more and more you understand the different terminologies and also what sets are, the better you understand all these things. Okay, with that said, if you do have any questions, please feel free to write them in the comments below. If you find any criticisms about my video, please feel free to put. I'm not going to be offended. I'm actually going to take them on to try and improve my teaching style, my instructional techniques, and so on. So, and I'm always learning. Every single time I do one of these videos, I'm learning too, and that's why I try to never cut out any mistakes. And I only cut out where I've maybe rambled on for too long, which I try to avoid. Anyway, with that said, thank you very much for watching. If you've watched all the way through to the end, give yourself a big thumbs up too. And it would really help me and other people if you gave this video a like or comment on it, because the comments, they help the YouTube algorithm to send it, to broadcast it to other people who would be interested in this topic. So by liking it, you're helping others like yourself to find this content. And if you did find it helpful, then it's a really lot of help to me to know that you found it helpful. Okay, thank you very much for watching once again, and there will be a video on the screen right now, more than likely the second video. So see you in the next video. Ciao, ciao, goodbye.